because they have yet to change that light bulb. We can almost see it with the lights on. Okay. So show that H is a subgroup of G under these operations.
Assume.
Yeah, assume, well, I chose light, but yeah. G be equal to that and H be that. There's a hypothesis. Easiest part of the proof, except for maybe the check mark at the end.
Or writing proof.
Or writing proof, yes. So let G be that. We have to show it's a subgroup, so we have to show that it's closed under the operation. We're talking about the function, the set of all functions over the reals. That's what f of r was from the reading here. What was the operation that the book told us to use for that? Addition. So we will do, take two functions in there and check it. So I'll call them f and g. Let f and g be in our set H. What does that tell us to be in our set H? What do we know about f and g? According to our definition, f of minus x equals negative f of x. That, by the way, says it's an odd function if you remember your pre-calculus. Oh, I got an extra f in there. And g of minus x is equal to minus g of x. So let's add them together. If we do f plus g of minus x, according to pre-calculus, this is f evaluated at minus x plus g evaluated at minus x. But according to our previous equality here, what's f of minus x? Negative f of x. And what is g of minus x? Negative g of x. So then that's equal to minus f of x plus g of x, factoring out our minus sign, which is simply equal to minus f plus g. Operating on x. What does that tell you? It's closed. F plus g is in H, and thus H is closed. Under addition. So what do we have to check next? Closed with respect to inverses. So we have to show that every element in H has an inverse. So we'll have, I don't know, we can have our f be in H again. Let f be in H. Then, what do I know? What do I think is going to be the inverse of f? We can't call it just f inverse. We actually have to figure out what it is. Yes, it's going to be called f inverse. Yeah, consider the element negative f, because f minus f is going to be 0. So consider the element negative f. Note that, and I have to show that negative f lives in H. So negative f of negative x is equal to negative, what is, if we evaluate f of negative x, what is that going to be equal to? Yes. And you have two minus signs, so that's f of x. So what does that tell us? Maybe we can just say with the previous sign. That'll make it a little bit clearer. Remember, to be in our group H, you have to just take that minus from inside and it has to come outside. And this is the minus that we have in front right here. So this tells us right here that negative f is in H. Does everybody follow that? For negative f to be in H, when you take that minus sign, it has to come out. So you can have two minus signs in a row. So that tells you, thus, yeah, negative f is an H. Now we just have to verify that it's an inverse, and we'll be done. So we're going to have F plus a negative F operating on X. We just want to see that it's equal to 0. This is equal to F of X minus F of X, if you will. We can add or put our two pluses, plus and minus together and get a minus. But what is that equal to? 0. For all X in the reals. Thus, negative F is the inverse of F. That makes sense? Draw your final conclusions. H is a subgroup of G. These proofs are relatively short. You only have to verify 2 things on them on your homework. So make sure that you have both of those things verified when you're going to do your homework. Any questions? No? Okay, we're done for today.